So here we have the valency method of 2-element compounds. So compounds that end in IDE only have 2 elements in them, and we can use the valency method. Now the valency methods I'm going to show you here are when you are considering, we're considering here. So when you look at your data booklet, remember, the group that an element is in determines its valency. So if you ignore the block in the middle, groups 1, 2, 3, 4, 5, 6, 7, 8, your valencies go up and back down from 1, 2, 3, 4, 3, 2, 1, 0. You must remember that. It's not in your data booklet. You need to remember that. The transition metals, because they don't belong to a particular group, they're given a Roman numeral next to their name, and the Roman numeral tells you what their valency is. So again, you need to remember your Roman numeral's really up to about 6, possibly even 7. So our first example here is boron fluoride. So when I'm using the SVSDF method, which is the valency method, my first thing to do is to write down the symbols of the elements present. So boron and fluorine. Secondly, V is for valency, so I write the valencies down. Boron has got a valency of 3, and fluorine has got a valency of 1. S is for swap, so I'm going to swap these over to become 1 and 3. And D is divide if you can, only if it's going to give you a simpler whole number ratio. When I've got a 1 there in my ratio, it's as simple as I can get, so I'm going to leave that as a 1 to 3. That means I have 1 boron and 3 fluorines. So my formula is BF3. Second one, I've used a Roman numeral in here. So again, I've got zinc Vi nitride. So zinc, my symbol for zinc is Zn. My symbol for nitrogen there is N. Valency, so because this is a Roman numeral, it has multiple valencies, so they have to give me it within the name of the compound. So Vi, V's 5, and the one's after 5, so that's got a valency of 6 there. Nitrogen in its group has got a valency of 3. Again, S for swap, so I'm going to swap them over. So I've got 3 to 6. Divide if I can to get a simpler whole number ratio. Now, if I divide both these numbers here by 3, that gives me a 1 to 2 ratio. And that means that I have 1 zinc and 2 nitrogens. So ZnN2. Okay, I've got another couple of examples just quickly to show you here. So I've got copper II oxide, so again a transition metal. So my symbols are going to be copper, and then my symbol for oxygen is O. Copper II, valency of 2 from the Roman numeral. Oxygen, go to where it is in the data booklet, it's in group 6, so its valency is also 2. Swap my valencies over, so I've got 2 and 2. Divide if I can to get a simpler whole number ratio. Whenever you've got the two numbers the same, you can always divide and take them to a 1-to-1 ratio. That's the same in any example. It's 3 to 3, 4 to 4. So therefore I have 1 copper and 1 oxygen. And finally, lithium sulfide. So lithium, Li, sulfur, S. Lithium's in group 1, valency 1. Sulfur's in group 6, valency 2. Swap them over, 2 to 1. Got a simplest whole number ratio I can get here, so I'm going to leave it as it is. 2 to 1, which means I have 2 lithiums and 1 sulfur. So valency method for compounds with 2 elements present.